This is Fun with Electronics Project 4 Part 3, where we design an LDR feedback circuit. So for the resistor, um, I'm using a 470 ohm resistor as well as the current limiting resistor. They're both 470 ohms. So the calculation that led me in using 470 ohms was due because of the voltage required in order to maintain the LED off. And for that to happen, I needed a voltage that was less than zero point 0.7 volts, which is the turn on voltage of that the transistor needs in order for it to turn on. More specifically, the base voltage, the turn on voltage. So yeah, which is connected through the voltage that that this resistor is producing. So basically, I made some minor calculations in this dirty paper, how to find something to write on, and this was like the closest like that I could find at this moment. Yeah, for this moment. So yeah, so I did. So I found out that the resistance that the LDR was producing at dark condition was around 38.9 kilo ohms and 430 ohms at light condition when using my phone flash my phone's flashlight. So yeah, so here are the calculations, which led me to 485. But I didn't have that in any of my like any of my storages. So so I had to just plug and play, and 470 ohms was seemed to be um, the safe point basically, and which I'll show in a minute. So here is a circuit right here, and and as you can see, it shows the resistor to be 1K, and this was before. So I had this circuit drawn out before this video, so that's why I had a 1K as just as a guess. But after the calculation, um, that's where I noticed that I needed a resistor that was less than 1K, which led me to 470 ohms. So yeah, so I'll change this and make sure this change happens during the in the report. So yeah, so just be aware that both of the current limiting resistor and the bottom resistor are both 470 ohms. All right, so for the transistor, it's not written, but I'm using a 2N3904 NPM BJT transistor. So yeah, so here's a circuit. As you can see, the LDR is facing the LED. So yeah, as you can see, both of these resistors are 470 ohms. So yeah, so let's test the circuit. So right now, we have a 9-volt battery connected to the circuit, which shows that the circuit is on. It's connected, and right now my lamp and this in the screen is not affecting. They're not affecting the circuit. So let's turn my lamp off. All right. And then let's shine the LDR with my flashlight, and there you go. It lights up, and now when I turn my flashlight off, it remains on. All right. Sorry about the quality. I plan on buying a new phone. Well, so now, what happens if we block the path between the LDR and the LED? What happens if we block that light that's coming off of the LED? So for that, I'll be using the backside of a soldering tweezer, and and when I do that, if I place it between, there you go. The LED turns off. Why? Because the LDR no longer senses any light, which um, lowers the resistance here, going below zero point 0.7 volts, turning the transistor off, turning the LED off. So yeah, let's do it one more time, just for the sake of it. So let me use my lamp this time as the light source. There you go. It's on. Let me turn my lamp off just for a better demonstration. Okay. And now we use the tweezers. And let me turn my phone's flashlight for a second to see if it's more. Yep. Okay. Yeah, I should have done that. Okay. Now, that we use the tweezers, I don't know if my phone's flashlight will affect the circuit, but since the LDR is facing away from my phone's flashlight, then I think it shouldn't be a problem. So if I cover the LDR with the tweezers, there you go. The LED